Let's talk about other kinds of code, or as I call it, none of the above. Because when we introduced the model view controller design pattern, the idea was that you shouldn't put code in your views because the only thing a view should do is have enough information for the user to interact with information from the model and give information back to the model, like filling out forms. We also said your controller methods should be really simple because the controller should be doing the minimum necessary to be the mediator between the views that the user interacts with and the model, which is where the business logic is, that manipulates the actual entities that your app cares about. So, does that mean that everything else, if it's not in a view and if it's not in a controller, does that mean it should go in the model? Hardly. And in fact, one of the sort of early critiques about Rails was that the models become extremely bloated and have all kinds of code in there that is not about the model. Now, what do we mean by that? Well, for one thing, remember that models in Rails are based on this abstraction called active record, which we described earlier in the course. Active record really just says that when you have a data structure that defines a kind of thing that your app manipulates, the storage of that data structure in a persistent storage, like a relational database, happens more or less automatically. When you modify the model, it changes the database. When you're searching through a collection of models, you're doing a database query. That's really the essence of active record. But there's a whole lot of code that goes into a typical non-trivial SaaS application that is not really just about that. And that code shouldn't go in the model either. So where else can it go if it's none of the above? We're going to distinguish at least three other kinds of code, playing three different types of roles, if you will, in your SaaS application. The first is code that you factor out functionality to keep your main classes slim. Things that are not about the model and how it's stored and the basic operations on it maybe can be factored out and moved somewhere else. Places where you need a little bit of extra help to make the view look nice, but you don't want to put the code in the view. That's one category. A second category is code that will help you dry out other parts of your app, or maybe even dry out repetitive tasks by automating them. And the third kind is code that encapsulates coupling among models. And this is possibly the most interesting category. So let's talk about some examples of each of these in turn. Factoring out code to keep your main classes slim. What are some cases where you'd want to do this? Well, if you Google presenter, as in model view presenter, presenter is some code that helps the views sort of do a better job of displaying complicated objects or letting the user interact with them. So they're related to what the view does, but you don't want to make them part of the view itself because we try to keep code out of our views. So that's one example of factoring out code. Another example is something that's called a value object. A value object is one where, for example, comparisons of the object are not based on its primitive type. Let's consider, for example, that you're creating an app in which you manipulate ranges of dates. So what does it mean for one range of dates to be less than another or to be equal to another? Or if you have an app that manipulates street addresses, what does it mean for one address to be closer to another address compared to a third one? So these are cases where you can encapsulate logic like that in its own class and call that a value object. When we talk about design patterns later in the course, we're going to learn two design patterns called adapter and decorator. And these are cases where you need to add some behavior to an existing class, but have that new thing essentially behave like a member of that class. So what's an example? Let's say you have an app where one of your classes, in fact, one of your models, is about storing some sort of a document. One variation you might want to have on that is, what if the document is encrypted or requires a password to get at? So that's not really part of the document model, because the document model is about how storing the document maps into the database. But you could decorate the document model with, let's say, encrypted document that has all of the behaviors of the underlying document, but allows you to also talk about the idea of it being encrypted. The second category is code that dries out parts of your app by extracting reusable behaviors that can now be used in different classes, like mixed in, or automating a repetitive task. So what are examples of these? One example of reusing a behavior across classes is sometimes called a concern. Let's imagine that you have an app that stores a variety of different objects that have big blobs of text. For example, reviews of movies or summaries of a movie. In Simple Rotten Potatoes app, those are two examples of a place where you might have blobs of text and you'd want them to be searchable. Now, relational databases by themselves don't give you much flexibility in looking up things in full text search, but clearly full text search is a behavior that would make sense to be able to add into either the movie reviews or the movie summaries. So Rails actually provides a way to mix in behaviors through Ruby's module mix-in mechanism. We met that back when we talked about duck typing. And concerns are a way to achieve that behavior in your app. It's a set of behaviors that can essentially be mixed into different models. And what about automations? Well, one kind of automation that comes up all the time in software as a service is when you're deploying a test version of the app for the customer to review, you might want to put some realistic but fake data in there so the customer can see what it's like to use the app, but doesn't have to risk an experimental version of the app mucking up their real data. So a task that knows the schema of the app and can create realistic staging data is a great candidate for automation. And in the case of Rails, Rake is usually the tool that is used to build those automations. What about encapsulating coupling among objects? This is one of the more interesting ones to me because it addresses the question of what do you do for a piece of app functionality that has to touch multiple models? So consider that you have an e-commerce app and the customer is about to finalize their order and buy something. Buying something is actually pretty complicated because it's going to affect the customer's order history. It's going to affect the inventory of the items being purchased. It might affect the revenue bookkeeping. So there might be multiple models or multiple tables that all participate in the single transaction of somebody buying an item. And a service object is a great place to incorporate all of that because you don't want the inventory model to know the details of the order history model. You don't want the order history model to know the details of the transaction and revenue model. So this is a place where you can encapsulate, right? You can put a boundary around, here is some code that actually has to know the details about all of those three things. And service objects usually don't get their own tables. They're usually stateless, but they encapsulate non-trivial logic that usually touches multiple models and has to really know something about how they all work together. That keeps the models from having to know too much about each other. Specific cases of service objects that often arise in software as a service, one of them is a form object. So in the simplistic case, when you start using Rails, when you present a form on a page, that form is usually related to a particular model. But you can imagine a form that touches multiple models. In fact, going back to our simple idea of movies and reviews, you can imagine that if the user submits a review for a movie, not only does that form do something to the reviews table, but you can imagine if the user has specified, a preference or a popularity rating, some other metadata that isn't part of the review, but makes sense to present with the review in the user interface. So now, all of a sudden, you have a form that isn't just dedicated to a single model type. A form object can encapsulate that dependency, so you don't have to sort of put code that knows about model B into model A. A query object, similarly, suppose you're allowing the user to run a query that actually has to touch multiple model tables. That means that the query logic has to know some details about each of those models' schema or schemata. So a query object is another example of a service object because, again, it encapsulates a dependency among multiple models. It keeps all of that dependency information in one place. And I guess sort of another special case is a policy object. So we've got things the user can buy, we've got express shipping, we've got all these options, and there is a question of who is allowed to do what in the application. For example, there's a reporting model, but the user probably isn't allowed to run financial reports if they're just a customer. That would be something that the back office accounting person does. So a model that encapsulates who is allowed to do what under which circumstances, so that, again, each individual model doesn't have to worry about those policies. It just has to know how to fulfill the functions that are intrinsic to itself. So that's kind of a small zoo of other types of code that if you don't know, if it doesn't feel like it belongs in a model, and you're pretty sure it doesn't belong in a viewer or a controller, here's a handful of choices for what it could be. Where do you put this stuff? Like, where do the files live? Well, there are a couple of cases where convention over configuration tells us the answer. In the Rails framework, the rake tool is the way that you automate workflows and tasks that are repetitive. So there's a subdirectory lib/tasks. That's the natural place for your rake tasks to live. In Rails version starting with version 5, there's a directory called app/concerns where you can put concerns like searchable, taggable, commentable, some of these behaviors that make sense to add to a variety of different model types. What about for the other stuff? There's no specific convention for some of the other stuff, but we highly recommend that you put it somewhere in a subdirectory underneath app. And the main reason for that is when you start your Rails app, everything that's under the app subdirectory gets automatically loaded, meaning that if you put stuff someplace else other than app, you have to go out of your way to load it, and usually you do that by modifying Rails load path. Not a big deal, but it's kind of one more thing to worry about if you don't have to. So the bottom line here is that we know we told you to keep your views free of code and controller methods really thin, but a bloated model is just as much a bad code smell as having code in your views and controllers. So be aware when you're adding something to a model file, ask yourself, is this really a core functionality, a core responsibility of that model? If the answer is no, think about what other kind of code it might be and where you can put it so that you don't pollute the model with more than it really should be responsible for.